equations. Okay, here we go. This is a lot of writing. Okay, here we go. To solve a multi-step equation, you're doing the same thing that we were doing yesterday. You just have to do more than one thing to get the variable by itself. So to solve a multi-step equation, simplify each side, then use inverse operations to isolate the variable. Our method is going to be the same as when we were solving one-step equations. Cover up the variable term. So in this case, our variable term is x, right? This 2.5x, cover that whole thing up. Cover that up and deal with whatever else is on the same side. So in this case, we have the minus 13. That's the first thing that we need to deal with. How are we going to get rid of the negative 13? Zigan?
Doing inverse operations.
Yes. So what should we?
Would be adding.
Perfect. We're going to add 13 on both sides. If we do it on one side, do it on the other side. With me so far?
Yeah.
Okay.
Is that a 15 or
It's a 13. 13. Then bring down what we have left, because we got rid of the 13, but we need to bring down the 2.5x. Is x by itself in positive yet? No. So this is why it's multi-step. We have another thing to do. Okay, now we look at 2.5x. What operation are we doing there? 2.5x.
multiplication, and then you have to divide.
Very good. So this means the coefficient, right? Coefficient. Great math vocabulary. The coefficient is 2.5. That means we're multiplying. 2.5 times x. So we need to do the inverse of multiplication, which is 2. Divide by 2.5. If I do it on one side, do it on the other side. So I'm going to divide both sides by 2.5.
So x would be 6.
Just, yeah.
My thought process was that if 5 goes into 15 3 times, half of 5 would go to 6.
But 7 times 2 is 14.
That's good. You lost me on that. I'm not a math in my head girl. That's why all this writing's over here. But that's very good, yes. It is 6. So, how? Here, I'm going to go back. I'll go real slowly through the...
1.5 is 50.
Okay, watch. If you literally do the long division, 15 divided by 2.5, right? 15 divided by 2.5, move your decimal. 25 goes into 156 times.
It does. That is nice.
And it's math also. Okay, so the solution is x equals 6.
I really thought it was like,
Well, you know. All right. And you can always check. Stop. You can always check your work, right? By plugging in, if we said that x equals 6, plug in 6 for x and check. And this works because 2.5 times 6 is 15 minus 13. Whoop, is 2. So we are right.
yay.
And you write so fast. Was it like a PowerPoint slide that just kind of spaced out?
So I wrote it already, is why.
So it's like a PowerPoint slide.
Yeah,
You're using like the thing where
of my
you write
writing.
it and then like you drag it across the shift.
Yeah, I can do that. Yeah.
Presses a play
Yeah.
button. And
I have it all set up where like it stops at certain spots.
So have you done this like before? Or are you doing
This is new. No, I've done it before. I did it like
How long did
at
you teach
home.
at St. Thomas More?
for 5 years. But this is new to you guys. I haven't done this before.
Are you a middle school teacher?
Mm-hmm. Okay. Here is our little mnemonic device to help us remember how to solve multi-step equations. DCAM, don't call after midnight. For me, it's like don't call after about 8 p.m. because then I'm asleep. But we'll say don't call after midnight to help us remember. Do you know?
I have another one, but it's fine.
You do? What is yours?
I think I forgot. Does McDonald's make raw cheeseburgers? It's like fries and then.
Oh, okay. Interesting. So we're going to say don't call after midnight. This is for solving multi-step equations. What it stands for in terms of the math that we must do is this. Distribute, that's the D, don't. So first you distribute if you can. Next, combine like terms. That's the C. So distribute, then combine like terms. So that's sort of the simplifying part of this. Distribute, combine like terms, then add and subtract. And this is when we're simplifying. Then add or subtract, and then finally multiply or divide. That's your last step. So that's where the DCAM. Distribute, combine like terms, add and subtract, then multiply and divide. And then at that point, your variable should be isolated when you do all those things. Okay? So that's our little device to help us. Now, don't get this confused. This is not order of operations. This is just solving multiple step equations. Okay, let's do an example. Example 2. Example 2 says negative 12 equals 9x minus 6x plus 15.
That's a lot.
Yes. Negative 12 equals 9x minus 6x plus 15. Zegan.
Would you like to simplify so you have 3x plus 15?
Yes. Yep, so I'm going to write my little, abbreviation, DCAM. Is there any distributing? Do I need to do the D part of this? No. So we're going to cross that one out. We don't have to do that. But we do need to combine like terms. Okay, my like terms are what, Zegan?
9x and 6x.
Very good. So we need to do that step first. We need to combine those like terms. 9x minus 6x gives us 3x. So we must do that first before we can start solving. Now we've done the C, right? We combined like terms.
How is it 3? Oh, you just said
9 minus 6. Yep. So just, again, the coefficients, we use those. Okay, now we begin our add and subtract, multiply, and divide. I prefer to do the cover up the term than solve, but it follows the same pattern. If we cover up 3x, we have a plus 15. What should we do? Subtract 15 from both sides. Subtract 15 from both sides. Okay, on the left, we're combining two negative numbers, so our answer will be more negative. What will it be?
negative 27.
Very good. Negative 27. Got it? Yes. Okay, so negative 27, we bring down that 3x. Is our variable isolated yet? It is not. We still need one more step, right? 3x means 3 times x, so we need to do the inverse of multiplication. Divide both sides by 3. Which gives us
Negative 9.
negative 9. Good? Okay. Let me see what else I have on this slide. Oh, just to check. Okay, again, we can always check by plugging in our original. Now, I messed this up at first, and then I had to erase it and do it again. Oopsies. So plug in that negative 9 wherever we saw an x, and then simplify. Okay, and then we end up with negative 12 equals negative 12. Correct.